confidence intervals in Excel. So this is a pretty good explanatory picture of what exactly a confidence interval is. We're trying to trap the true population mean by taking information from a sample. So the X bar is the sample mean, plus or minus. Everything over here is called the margin of error. The plus or minus factor right here is called the margin of error. The Z star tells you what level of confidence you want, right? 90%, 95%, 99%. And this is times the standard error. So it's not that hard. Please look this stuff over. And it's got, you know, if you're going to do it by hand, which we're not, this is the Z star score that you would multiply back in the original formula for the different critical levels. We're not going to do that. Here's a good one about confidence intervals and what it looks like in a picture. Okay, so again, we're trying to trap the true population mean. So here we go. So here's the mean from the problem, standard deviation from the problem, sample size from the problem. We are not going to find the standard error here. In other words, we're not going to divide the standard deviation by the square root of the sample size. We don't need to because the formula does it for us, okay? So let's just pick a cell right there. We're going to calculate the margin of error using Excel. That's when we're going to type in this formula. Just start typing equals confidence, and it should pop right up. There it is. So what you have to remember is that the critical alpha, the cutoff alpha, plus the level of confidence, the confidence interval, has to equal 1. So if we're looking for a 99% confidence interval, that means our critical alpha is going to be 1%, or commonly called 0.01, comma. Standard deviation is 4.8. And again, we do not divide that by the square root of the sample size, because if you'll notice, the next thing in there is the sample size, and the computer's going to do that for us. Close parentheses. Bam. So there's our plus or minus. This is what I call wiggle room, our plus or minus factor. Okay, so we're going to add that to the mean and subtract it from the mean. So the lowest point is going to be equals, it's going to be the mean minus that number. So there's our low value. And for the high value, we're simply going to go equals the mean plus that margin of error. And there's your high value. So what this literally means is that the true population mean for these IQ test scores for 8th graders, taken 300 at a time, should be somewhere between 102.89 and 104.31. And we're 99% sure that should happen. Okay, that's how you do that one. Problem 2, Hershey's Kisses. Yummy, yummy. They're normally distributed. It's very important. None of this stuff works unless the data is normal. In other words, it fits a normal distribution. In other words, again, most of the data is around the mean. That's what normal means. Okay. So we have a sample size of 100. Our mean is 8.2, standard deviation 1.2. So I'm going to start with problem C. What's the margin of error? Because that's basically what this thing is doing. When Excel calculates a confidence interval, it simply finds the margin of error, and you have to add it and subtract it to the sample mean. But I'm going to pick that cell right there. I'm going to go up here. I'm going to start typing equals confidence. It's going to pop up. Confidence norm. So our alpha on this one, 90% confidence interval. That means the alpha is 10%, commonly called 0.1, comma. Standard deviation is 1.2. We do not divide that by the sample size because Excel does that for us, and our sample size is 100. All right, so there's our margin of error. That's our wiggle room. That's our plus or minus factor. Now I'm going to go back up to the top one. They want the confidence interval for the true population mean, so I'm going to go to that cell. I'm going to type in equals. It's going to be the mean minus the margin of error. And the other one's going to be, the high is going to be equals. It's going to be the mean plus the standard of error. And there's our high number. So let me make these pretty for you. Okay. So the true population mean, hopefully, 90% sure, is going to be between 8 and 8.4 grams of those Hershey Kisses. And the 90%, what are you confident about, is if you repeated this process and measured these kisses 100 at a time, then 90% of those sample means, 90% of those sample means should fall between 8 and 8.4 grams. So that's what that means. All right, moving on. Another confidence interval problem, but this time you have to figure out what the mean and the standard deviation is and the sample size. And I'm going to show you a trick here. You'll notice that the actual data is in one cell. So give me a second. I'm going to copy and paste this into another sheet here. So there's the data. It's all in one cell. I'm going to show you guys how to turn this into a column. So first thing you're going to do is you're going to go to the Data tab, and then you're going to go to Text to Columns. And we're going to use the delimited characters such as commas. We're going to use the commas to separate our data into individual rows. We're going to collect comma. You'll see you get a little preview here, and this is just what we want. We want finish. So each data set is now its own cell. So what we're going to do is highlight them all, right-click copy, pick a cell, any cell, right-click paste, but we're going to take this transpose. See that one right there is transpose, turns it into a row. So now turns it into a column. So now I'm going to take this column of data, and I'm going to go put it back on the right problem here. And we'll just work from here. Paste. There it is. Okay, so now we want the mean and the standard. Let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Ah, that's a good size. So there's 16. And let's go ahead and get the mean. We just type in equals average. Double click, and it says average from what? You want to highlight your data here. I want my mean from that data. Just hit enter. So there's the mean. I only want two decimal places. And then up here we do the same thing. Equals St. Dev. And we always go with the S. That means sample. And the same thing. It's asking you, what do you want the standard deviation of? Go ahead and highlight your data set. Hit enter. And there's your standard deviation. So we have everything we need to know to build a confidence interval. Let's go ahead and just pick a cell, any cell. Equals confidence norm. There you are, number 2. So we want a 95% confidence interval. That for our alpha level is going to be 5% or 0.05, comma. Standard deviation, we just figured it out, 0.33, comma. And our sample size is 16, close parentheses, hit enters. All right, let me clean that one up a little bit. So there is our margin of error. So our confidence interval is going to be low and high. Or low is going to be it's going to be the mean of, where'd you go up there? So it's going to be the mean minus the margin of error. And the other one's going to be the mean equals the mean plus the standard of error. The margin of error equals. So there's your confidence interval. 95% confidence interval that the true mean weight for 16 of these nails should be between 7.28 and 7.60, 95% of the time. Okay, so in other words, we're trying to capture the true population mean of these nails. All right, moving on. All right, another confidence interval. Oh my gosh, these are getting boring. But confidence intervals are very important in the world of statistics because that leads up to whether you reject a null hypothesis or not. And again, that's coming. So the mean from this sample is 0.9743. Let me get these guys in the middle and make them big so you can see them. Get over there, you. Boom. Standard deviation, 0.02. And how many times did he did this? 10 times. So sample size is 10. Boom. So we're going to go ahead and I'm just going to pick a cell, any cell. I'm going to go up there and type in equals confidence norm. And we want a 90% confidence interval. Therefore, our alpha is 10%, commonly called 0.1, comma. Our standard deviation is 0.02, comma. Our sample size is 10, close parentheses, equals. So there is our margin of error. Not very big. Okay. So our confidence interval is going to be, the low side is going to be the mean minus the margin of error. So that's the low boy. And the high boy is going to be the mean equals the mean plus the margin of error. And so whoever owns this gas station is in serious trouble. You know why? Because it's not putting out a gallon, right? The person doing this test is 90% sure that the average gallon that this machine is putting out is really between 0.964 gallons and 0.9585 gallons. So the government's going to get him. Okay, so that's the confidence interval for this. Let's go ahead and do the sample size with a margin of error of 1,000th. Okay, for that one, we're going to have to break out the formula because Excel doesn't do sample sizes, but it's pretty basic. We're just going to go to the sample size. We're going to use that formula. So our minimum sample size is the confidence interval. So that's 90%. We got to figure out what that number is, but I have that here somewhere. Hold on. There it is. So we want a 90% confidence interval. That means that Z star score is going to be 1.645. So it's going to be 1.645 times the standard deviation. Whatever that is going to be divided by our margin of error, and that is our 0.001. And whatever that quotient is, we're going to square it. So let me switch over to the spreadsheet. I'm just going to start typing in numbers. The Z star was 1.645, right? That was our Z star. And our standard deviation was 0.02. And our margin of error from the problem is 0.001. So now we're going to have to multiply these two, divide by that. Hold on a second. Let me make them bigger for you. More better. Okay, so let's do Z star. I'm going to just put in equals. I want that cell, shift 8, that's the asterisk, times the standard deviation. Enter. And now I want that number divided by M. Going to go equal that number backslash underneath the question mark divided by that equals, and now I'm going to square that number. Just going to go equals, please take that cell, shift 6, it gives you the caret that tells the computer the next number coming is an exponent of 2, bam. So there's your minimum sample size right there. If you want a margin of error of 1,000th, which is a real fine margin of error, and you only want a 90% confidence interval, you should have done at least 1,082 different trials there. So that's that one. So this last one is a sample size question as well. If you remember the formula, minimum sample size is going to be the confidence interval, the Z score related to that, times the standard deviation divided by the new margin of error. You square that whole chimichanga. So let's get that information. So we're looking for what, a 99% confidence interval this time. So a 99% confidence interval would give us a Z star of 2.576. 2.576. I think I had a phone number that started with that once. Standard deviation 4.8. And our new margin of error is anything after the plus or minus sign. So it's 0.05, 0.5, 0.5, 0.5. Okay, so what we're going to do is a little bit of math. Equals, I want the Z star, shift 8 times the standard deviation equals. Now I'm going to take that number and I'm going to divide it by the new margin of error. Bam. And last but not least, I'm going to square that bad boy because the formula tells us to. Equals, please take that cell, shift 6, should be the cell, right? That's E11, right? 24.73. Shift 6 gives you that little exponential caret, and in 2, because we're squaring it, hit equal. And that should work. Boom. So a minimum of 612. You always round up with samples, okay? So 612 minimum sample size is what they should be doing to get a 99% confidence interval using a margin error of half a point. So that's it. Practice, practice, practice. MGZ out.